Ladies and gentlemen, good morning, very good morning. Today is Saturday, 1st July 2023. This is the first webinar of this month. We have over 725 people who are registered. So we're expecting at least 70% to turn out for this webinar. We just finished on Thursday on HPI, Hospital Audit, Electrical Audit course that has been initiated by AHPI and NFE. So we have over 500 participants there. And today, very specifically, we are talking about electrical safety, earth and unearthed system. Today's speaker is Mr. Shivakumar. And in this session, we will explore the significance of unearthed and earth system in various industry, discuss its practical application. Understanding the importance and practical application of these systems is essential for electrical engineer, installers, and professionals working in various industries. We hope this webinar provides valuable insight and encourages further exploration of unearthed and earth system in your perspective field. So once again, thank you very much for joining, and we look forward for an interactive, informative discussion. This whole webinar is an initiative of National Federation of Engineers for Electrical Safety. I'm aware most of our participants today are member of NFE. It is just a 4 months old association. Within this 4 months, we have done over 6 seminars in all over the country, and we have now started webinars for over 6 webinars. So in very short period, we are able to cover almost 11,000 people in various subjects that we are talking about electrical safety. So we are a group of passionate electrical engineering professionals working in the field of electrical safety. Our members have decades of experience in working with electrical inspectorate of state, central government, electrical designer, MEP consultant, safety officers, and in the field of quality and standard. Vision is very clear. We want to make our nation electrically safe. So the recent introduction of NEC, National Electrical Code 2023, and CA Regulation 2023. So we are doing mass awareness program about this standard. So today, I will be the host for today's program. I come from a fire, background for over 34 years. I'm a founder and past president of FSA, Fire and Security of India, and we also have an association called Forum of Critical Utility Services, and of course, National Federation of Electrical Engineers. I am responsible in conducting programs and events, and also taken the responsibility to go global, to bring in all the professional world across under NFE. Today we have Mr. Shivakumar. He was the training professionals in L&T, and he's also a proud member of NFE. He has over 40 years of experience of a wide variety of low voltage, medium voltage, high voltage, extra high voltage, electrical equipment in various electrification projects and process industry. He has been conducting training programs on various electrical engineering topics. As I said, he worked as a manager training with Switchgate Training Center of L&T. We are expecting our moderator, Mr. Gopakumar, to join today. He is in Bangalore. He is with Institute of Engineering, invited where ministers and state government of Karnataka are known. I now invite Mr. Kumar to talk about the topic that we have highlighted today. And I request all the participants to put your question answer only in Q&A.
Yeah. So many
Okay,
things are
please
there.
put your question in Q&A chat box. You cannot put any
That's
question in
better.
chat box. I now welcome Mr. K. Shivakumar to take it forward. Over to you, sir.
Yeah, good morning. My name is Shivakumar, and I'm an electrical engineer having more than 40 years of experience in various aspects of electrical engineering, like right from design to commissioning to operation maintenance. At present, I am working as a freelance consultant, and I am giving consultancy to a couple of switchgear manufacturing units in my native place, Salem. And I have been handling training programs in L&T. I was about 10 years, I was a training manager for L&T, and earthing is one of my passionate subject. Today, okay, whatever maybe the topic say, but earthing is such a vast topic. We used to talk 18 hours on earthing. Our course syllabus was to introduction to earthing itself was around 18 hours. But in this 1 hour, to make a start with, we will discuss unearthed system. We will analyze unearthed system. And maybe in subsequent webinars, we will discuss earthed systems one by one. So today's topic of discussion will be unearthed system. Please reserve your question answers. I'll be open to answer your queries at the end of the session. So we will move forward to the session. Today's discussion will be on unearthed system. As you know, the definition for unearthed system is it is a system of conductors in which there are no intentional connection to earth. As you know, in an earthed system, we intentionally connect the source neutral to ground. But in an unearthed system, we do not make any intentional connection to ground. So an unearthed system is, we don't make any intentional, maybe unintentionally during faults, there may be a connection established with the earth, but we do not do it intentionally. This system is classified as unearthed system. So generally the scheme will be something like this. There will be a source may be a transformer or a generator, a 3-phase 4-wire system or 3-phase 3-wire system, or with a distributed neutral or without distributed neutral. The neutral, as you can see, is not earthed anywhere in the network. A typical scheme will be like this. So this unearthed system is a system in which there is no intentional connection to earth. As you are aware, in an earthed system, we are intentionally connecting the neutral to earth. So in an unearthed system, it is not done. The network will look something like this. Source may be a generator or a transformer, 3-phase or 3-phase 3-wire or 3-phase 4-wire, the distributed neutral may or may not, but the neutral is not connected to earth either directly or through any impedance. It is not connected to earth. This will be the typical arrangement of the unearthed network. But even when we say it is an unearthed network, whether you like it or not, there will be capacitive coupling prevailing between each conductor and the earth. Because as you know, two conductors separated by a dielectric is a capacitance, and wherever there are two conductors, two plates separated by a dielectric, a capacitance is formed. Here also in this network also there will be conductors, there will be dielectric. If you take a overhead line, distribution line, there will be a overhead line will be the one plate of a capacitor. Natural ground will be the another plate of a capacitor. The in between dielectric air will be acting as a dielectric, and there will be a capacitance formed. So there will be an imaginary capacitive coupling, even though we cannot say wired coupling. There will be a capacitive coupling throughout the system. It will persist, even though we say physically unearthed, it will be capacitively earthed system. There will be a capacitive coupling. Any conductor, even you take a cable also, there will be a conductor and armor, and in between dielectric will be there. So wherever there are two conductors and a dielectric, there will be capacitance formed. In fact, all unearthed systems are capacitively coupled earthed systems only, to be more precise. So this will be like this. R phase with the earth will have a XC R, Y phase will earth will have a XC Y, blue phase will to earth will have a XCB. This capacitance will be there in the system. Capacitive coupling will be there. So suppose we do not assume there is no earth fault in the system, the line to earth voltage will be equal, the three-phase line to earth voltage will be approximately equal, because we presume that the capacitance is equally distributed. We presume, to simplify things, we presume that this is equally distributed. Now, do not think very complicated coupling, capacity coupling, all those things. Just look at this picture. If you say that this system is unearthed, the R phase is touching the metal of the load, metal enclosure of the load. A person is in direct contact with the metal enclosure. Worst condition, wet foot, barefoot, wet floor, all those conditions you assume. Generally speaking, there will not be any closed circuit here, because the person is standing on earth, but neutral is not connected to earth. So there is no closed circuit. So for a basic understanding, there will not be current flow through the human body, even in this condition. Leave alone high-end complicated subject of capacitive coupling, we will come to that later. But to start with, understanding a basic, since there is no closed circuit, there will not be any current flow, even in the case of a single phase to ground fault. We will come to the intricacies later. To make a start, we will understand that since this is a closed circuit, there will not be any current flow. So the current is a matter of, shock is a matter of current flow through human body. So let us make an understanding at present that since there is no closed circuit in this system, there will not be any, even though voltage is prevailing, there will not be current flow through the human body, and there will not be any shock. So the first big advantage of unearthed system is there is no shock risk, even in the event of a line to earth fault, assuming that the capacitance is negligible. Capacitances are negligible. If the capacitances are significant, yes, the capacitive discharge may affect the person. But to simplify things, we will assume that negligible capacitance is there. Now, even though the system is not connected to earth, a capacitive coupling exists between the conductor and earth, due to which, whenever there is a capacitance, there will be capacitive currents flowing in the system. So you can see, when we have XC or XCY and XCB, you will also have ICR, ICY and ICB. This capacitive currents will start flowing in the system through the earthed capacitor, coupling capacitor. The capacitance earth of each phase is distributed evenly over its entire length, and for calculation purposes, we calculate as a single bulk capacitor. For calculation, simplicity of calculation, we assume this to be a bulk capacitor connected between each phase and earth. If the load is, we assume that the load is balanced and the conductors are symmetrically spaced. So when you under these conditions, since system is balanced and the conductor spacing is symmetrical, there will not be any residual fluxes, there will not be any residual voltages. We say that the neutral and the earth are at the same potential. Earth potential is always assumed to be zero. The neutral potential is also, in this condition, balanced condition and symmetrical spacing, neutral potential is also zero. So we say that the neutral and the earth are equipotential points. So in such a case, neutral and earth potential are same. The voltage of each phase with respect to earth will be equal to voltage of phase and neutral. That is called the phase voltage. So now VRE is equal to VYE is equal to VBE is equal to phase voltage, that is line voltage by √3. Voltage across the capacitor will be equal to the phase voltage. That each phase and neutral earth capacitor will be impressed upon the phase voltage of the system. The capacitor current in each phase, ICR, ICY, ICB, we assume that this will be I, will be equal to V phase by capacitive reactance, which is equal to 1 by 2 pi FC, where C is the capacitance between the phase conductor and earth. This capacitance value will be very small and the XC value will be very large, because we say the dielectric distance is very high, so capacitance value is small. So since the capacitance value is small, 2 pi XC is 1 by 2 pi FC, so the capacitive reactance will be very high. Since the capacitive reactance is very high, currents are very small, negligible. These charging currents are almost negligible, equal in magnitude and 120 degree out of phase, and 90 degrees leading the voltages, like this. You can see ICR is leading VRE by 90 degrees, ICY is leading VYE by 90 degrees. ICB is leading VBE by 90 degrees. Like the voltages, they are also 120 degrees apart. Now assume that R phase has got earthed in the network. Somewhere R phase got earthed. Now what happens? Since in the XCR capacitor, top plate is also in R potential, bottom plate also in R potential, there will not be any potential difference in the XCR. So there will not be any current flow in XCR. XCR, both the plates are having the same potential. Since there is no potential difference, there will not be any current flow. But you can see XCY, ground side plate will be impressed upon R phase voltage now. Earlier it was neutral voltage or zero voltage. Now it will be impressed upon R phase voltage. So also for XCB. So the capacitances XCY and XCB will receive line voltage and not phase voltage now under this condition. That is what is explained here. Voltage VR will shift to ground. Capacitance between R and ground will be short circuited by the fault. The voltage across Y and B with respect to earth will now be equal to voltage between phases. As E is no more E, E has become R now. So VYE and VBE will become VRY and VBR, which is the line voltage, that is √3 times the phase voltage. Since the voltage, phase voltage has become line voltage, now you can see the current also will be leading the phase voltage by 90 degrees. That is ICY and ICB. ICY will be leading VYB by 90 degrees. And ICB will be leading VYB by 90 degrees. If you can see, the total net current flow during this fault current, the capacitive discharge current is the fault current. It is the vector sum of ICY and ICB. So ICY and ICB, if you add the voltage, so since the voltage is increasing by √3 times, the current also will be increasing by √3 times. Earlier it was V phase by XC. Now it will be √3 V phase by XC. So the current will be no more I, it is √3 I now. Each ICY and ICB will be √3 I now. So if you vectorially add √3 I and √3 I, it will become 3I. So also earlier neutral and earth were at the same potential. So there was 0 volt between neutral. But earth is now R phase. So neutral and earth voltage will be neutral and R voltage. So neutral will show phase voltage now, because one end is R phase, earth is R phase now, and the voltage between neutral and earth will be voltage between R and neutral, that is phase voltage. So this is neutral will shift itself. No more, there will be huge voltage difference between neutral and earth. Neutral will shift from its 0 voltage to equal to phase voltage now. And this will create its own set of problems. Now, the two capacitors will discharge into the fault, will feed into the fault, and the magnitude of the fault current will be equal to the vector sum of the phase currents, that is √3I and √3I, which will become 3I. Like this, in this triangle, you can do the trigonometrical equation. The vector AB will be equal to 3I actually. Now, you need not worry, even when raised by 3 times, the capacitor currents are still very low in magnitude. So the fault current is very low. Typical values are in 415 volt systems, they say it is about 5 ampere. In unearthed system, the capacitive discharge current, fault current will be 5 ampere. And in 11 kV and higher systems, it is typically about 25 ampere only. So no overcurrent protective device. You provide a overcurrent relay, you provide a short circuit relay. These relays are set to 100% and more. So this 25 ampere or 5 ampere does not get sensed by the OCPD or SCPD in the system. So even in the, since there is no fault tripping, fault detection and tripping are not there, continuous supply, uninterrupted supply continues in the system. So this was perceived to be the second advantage of the ungrounded system. I say this was perceived. The very objective of the power system engineers will agree with me. The very objective of the power system is to supply electric power to the end user, even in the worst conditions. So Even in the worst condition of a single phase to ground fault, there is no interruption. Power supply will continue to go to the customer in ungrounded system. So not surprisingly, it was believed that in ungrounded system there will be service continuity even when there is a single line to earth fault. So at least until the 1940s, perhaps until the Second World War, only ungrounded systems were popular. There are a couple of the other day I was seeing a reference to some this KHA techniques of Schneider Electric. In KHA techniques, there is a book on evolution of earthing. So that also very clearly says up to 1940s, these unearthed systems were very popular. But then, if it is so advantageous that there is no shock risk, current is not very high, fault currents are not, earth fault currents are not very high, and there will be service continuity. In spite of all these things, no, we do not practice unearthed system at all. We are much familiar with earthed systems. So there must be some disadvantage in the unearthed system. Let us discuss the disadvantages of the unearthed system. So the biggest disadvantage is during an earth fault, transient over voltage happens in ungrounded system. Let us analyze what happens. Under certain line to ground impedance condition, the ground circuit will contain inductive reactance and the voltage of the healthy phases may rise further. That is, it may even go to 5 to 6 times or more. Let us see. We call this condition as resonance and ferroresonance conditions. We will see how it goes. Also, this may tend to swing the system to an unstable state. There will be causing arcing grounds because the voltage to the earth keeps on rising. There will be a tendency for the arc to strike between the face and the ground or the face and the earthed conductor. So this will lead to the failure of support insulator and the equipment connected to the system line, align insulators and terminal equipment. There were reports of failure of equipment, insulators and all because of this arcing ground. So the magnitude of over voltage, there are precise calculations available which we will see, will depend upon the actual inductive reactance introduced in the circuit. What is the content of the inductive reactance? Now, the unintentional introduction of an impedance in a ground leakage capacitance circuit is a result of a ground fault in the main equipment such as generator, transformer or induction motor. When any of these windings get earthed like this. This is a network, there is a source and there is a load. If you can see, the one winding of the load has got earth fault is there. You can see the current flows, the direction of the current flows. There will be ICR, ICY, ICB and through the load, there will be current flow. The capacitors will charge and discharge through the load. Capacitors will feed into the fault through the load now. Now, under such conditions, they will introduce their own inductive or resistive impedance or a combination of them into the ground circuit. Now it is no more only capacitive current. It will be a mixer. It will be a series circuit of R and C or XL and XC or R, XL, XC circuit depending upon the proportion of the components. So, moreover, it need not be that the fault happens inside the load or the source. Even if there is any system fault, in the network there is a fault, the impedance will be introduced into the ground circuit like this. If you can see this circuit, in this circuit also the fault is not in the equipment. The fault is outside the equipment in the network cable or the network line. You can see here also the load inductance, the load impedance is introduced in the ground circuit. You can see the current flow diagram. But the capacitor will now how it is discharging into the fault. Now it introduces one more impedance. Apart from the capacitive reactance, it introduces one more impedance in the circuit. Depending upon the type of the load, it may be a resistive impedance or it may be an inductive impedance or it may be a capacitive impedance also. There are three possibilities or a mixture of all the three. So now ground fault may be, so as you have seen in the above two diagrams, whether the fault is within the equipment or whether the fault is outside the equipment, there will be added impedance in the earthing circuit. So this added impedance, if you draw the equivalent circuit of the added impedance, you can see the voltage to earth is VL by root 3. There is a network impedance is there, resistance is there, and the ZG is the new impedance introduced into the ground circuit by the fault. So XCG is the ground capacitance. It may be XC R or XC Y or XC B. So you can see this ZG is the total impedance, sum of Z dash G plus XCG. Z dash G is the additional impedance introduced in the ground circuit during fault conditions. So V dash G is the voltage developed across the external impedance. Now we have three possibilities. Resistive impedance. If Z dash G is a resistive impedance, Z dash G is a inductive impedance, Z dash G is a capacitive impedance. Possibilities are there. So we will see what are the various transient over voltages developed under these three conditions. So under the above situation, ground fault within the load or ground fault outside the load, the ground circuit may give rise to dangerous voltages in the healthy phases. So the first situation is ZG is the external impedance introduced in the natural leakage ground circuit as a consequence of a fault inside the load or outside the load, either inside the load or outside load. Then the voltage across the external impedance can be calculated as per this formula. So VG it will be 71%. See, it is simple mathematics. If it is 1.5 times XCG, it will be 83%. So if you see as R is voltage developed across the external impedance equal to root 2 VL. So this is not dangerous because this is designed for that. Any equipment designed for RMS value is capable of withstanding its peak voltage also. Next case is capacitive reactance. Assume that the external impedance is purely capacitive. So you can, instead of R, you put capacitance XC value. So the denominator XC by XC plus XCG. They will arithmetically add because they are in the same direction. They will arithmetically add. So here also you put various values for external capacitance. If the external capacitance is 0, if the external capacitance is 50% of the leakage capacitance, 33% voltage. If the external capacitance is 100% of the leakage capacitance, 50% voltage. If the external capacitance is 150%, 60%. If the external capacitance is 200% of the leakage capacitance, 67% voltage. So if you keep on giving values, if the XC approaches infinity, so the maximum value will be root 2 VI maximum. Because if you see, as this fellow goes on increasing, this becomes negligible. This becomes almost 0. So 2 by 2 equal to, this 2 by 2 will be equal to 1. 1 into root 2 VI, the maximum value it can reach is root 2 VI only. Here also, like in resistive impedance, as XC approaches infinity, the maximum voltage, the impedance during fault, the load or the network will see is root 2 VI only, because that is also not to be worried, because this system is designed for withstanding a peak voltage of root 2 VI, BL actually. Now, the voltage developed across ground capacitance XCG and the external impedance R or XC is shared in the ratio of their own values, the sum total of which will remain constant at root 2 VI. Now, if you introduce an inductive reactance, if the external impedance is inductive reactance, which is the case in almost all the networks, because we use more of inductive loads in our networks. So the external impedance is predominantly inductive. Now the situation is different because there is a possibility of XL resonating with the XC. We will see. Now inductive reactance, you put the same formula, XL by XC minus XL. Instead of R and XC, you put XL values here. Now the same formula. Now if you see 0 means 0, if external impedance or inductive reactance is 50% of the capacitive reactance of the leakage network, you see 100% root 2 VI is introduced. If the external impedance is 100% of the leakage capacitance, so XL equal to XC. Whenever XL equal to XC, it is called a resonance. So you can see the voltage is almost infinity. It is not practically infinity because the network also contains some resistance. So the resistance to an extent reduces, but it is very high. Whenever the external impedance happens to equate the leakage capacitance of the system, there is a tendency of the voltage appearing across the external load going towards infinity. That is, very high voltage will be thrust upon the equipment and system during single phase ground fault in an unearthed system. So this is known as resonance condition. It is however seen that in view of the some inbuilt resistance in the ground circuit, it will be attenuated, not practically infinity. There have been calculations. It is seen that the voltage will float between 8 to 10 times the root 2 VI. This has happened because our equipment are not designed for withstanding this voltage. So there is a chance of equipment damage and system damage. So this will tend to voltage raise the ground potential substantially depending upon the value of the external impedance. So it will also raise the potential of the healthy phases, which may cause arcing grounds and become dangerous to the line insulator. This is called resonance effect. Further, if you increase it, suppose if you keep on increasing, you see it starts coming down. It is like an inverted parabolic curve, starts from low value, go to a peak and coming down. So if it is 1.5 xg, it is 300%, 2 xg, it is 200%, 3 xg, it is 150%, 4 xg, 133%. So if you keep on increasing, it will start dropping down. So one particular resonance, it will high. So when you keep it infinity, again as seen in the case of resistance and capacitance, it will maximum come back and settle down at root 2 VI. So the danger here is whenever the system network inductive reactance is equal to capacitive reactance during an earth fault, there will be very high over voltage thrust on the system, which is not good for the system. So the disadvantages, summing up the disadvantages of the unearthed network, as we have seen in the previous slides, there will be huge transient over voltages during a single line to ground fault, causing damage to system and equipment because we cannot design our system to tolerate this high voltage because it will make our system and equipment costly. So we generally economize in our design. So when we design our system for tolerating nominal over voltages, when unearthed system, when this happens, system and equipment get damaged. So even though next we said that there will not be any power interruption during a single line to ground fault. So it is a big advantage. Practically it is not so. Even though the single line to earth may not cause a power interruption, it will cause a second line to earth fault sooner than later because the ground potential has now become phase potential during a single line to ground fault. Then the second phase and the third phase to earth voltage has increased, its insulation will be stressed. So sooner than later a second line also will get grounded. There have been instances of immediate second fault in the system. So the voltage of it will soon cause a second line to ground fault as the voltage of the healthy line to ground during the first line to ground fault will have increased by root 3 times. Thus, the insulation, phase to earth insulation of the healthy phases is stressed now because the voltage has increased, it is stressed. So, more sooner than later, there will be a second earth fault. Whenever a second earth fault happens, the fault becomes a line to earth fault. It is no more line to earth fault, it is line to earth fault, it is double line to ground we call. Now, the system OCPD may not detect a single phase ground fault, current is negligible. But when this becomes a line-to-line short circuit, definitely the currents are huge. So definitely the system OCPD or SCPD, over current protective device or short circuit protective device, will operate as the face-to-face short circuit current is very high, even kiloamperes. So definitely there will be a power interruption. So whatever we have earlier told initial for understanding, we told the advantage of ungrounded system is no interruption is lost. The advantage is lost. So because single line to ground fault will never remain single line to ground fault, it will soon culminate into a second line earth fault and ending up in a line to ground fault. So this line to line fault is current is more and the breaker trip or fuse will blow causing interruption. So that advantage is definitely lost. And as I said, arcing grounds, because there is a potential jump. It will between earth and healthy phases. It will keep creating, trying to strike an arc. So these arcing grounds are also causing damages to insulators and the terminal equipment. There are records of damages caused to terminal equipment and insulators. So this is another big disadvantage. And if you do not want to if you want to avoid these damages due to over voltages or higher voltages, you generally have to design the insulation for line voltage and not for phase voltage. Because during earth fault, these healthy phases will see a line voltage. So generally, you have to design your system for line voltage. That is why they say unearthed cables, cables for unearthed system and cables for earthed system. So cables for unearthed system are generally costly. If they say 11 kV E or 6.35 kV UE. So in fact, for 6.6 kV UE system, you have to practically use a 11 kV cable. So 11 kV E is equal to 6.35 kV UE system. So every time an unearthed system is there, you have to use a higher rated cable, higher rated equipment. So that will make your system costly. Similarly, when you see the PT standard, potential transformer standard, the over voltage factor is very less for grounded systems. If you see, it is for solidly earthed system, it is 1.2 continuous and 1.5 for 30 seconds. So if you see the unearthed system, it is 1.2 continuous and 1.8 for 8 hours. So if you order a PT with a higher over voltage factor, it has to withstand 1.8 times the rated voltage for 8 hours. Definitely the CT will be costly. CT will be bulky and costly. If you want to use the PT in unearthed system, definitely you must go for over voltage factor of 1.8 for 8 hours. Similarly, if you see the surge arrestor rated voltage calculations, it depends upon something called a ground fault factor. The ground fault factor is a 0.2 for solid 0.8 for solidly grounded systems, and it will vary from 0.8 to 1.732 as high as it is 1.732 for unearthed systems. So definitely for unearthed system, if you want to use a surge arrestor, you have to use a higher rated voltage arrestor, which will make the arrestor bulky and costly also. So these are some of the disadvantages of the unearthed system. Sorry. So because of the above disadvantages, because people later thought it is easy to manage current than to manage voltage. So people thought that earthed systems are better. So the world also moved towards earthed systems. From unearthed system, world slowly moved towards earthed system, and predominantly we can say that most of the countries follow earthed system. It could be directly earthed, or it could be resistance earthed, or it could be impedance earthed, reactance earthed, or Peterson coil earthed, or whatever may be the earthed system. Most of the networks in the world are today practicing earthed system only. Unearthed system, yes, there are certain installations where service continuity of paramount importance, say in hospitals, maybe where operation theaters or critical diagnostic equipment are there. They don't want power interruption during a surgery or during a diagnostics where the results may be tilted. So people still, for locations where service continuity of important, they go for unearthed system. The network is split. In such cases, the network itself is split with separate transformers. One transformer with earthed system for normal system, one transformer with isolated neutral for special areas like hospital, operation theaters, diagnostic rooms, and certain nuclear establishments also. They want unearthed system. They don't want supply continuity to be disrupted. So unearthed systems are now confined to very minimal locations. So maybe in a subsequent seminar, we will slowly graduate into discuss the various advantages and disadvantages of each method of earthing, like resistance earthing system. What are the advantages, disadvantages? The reactance earthing system, what are the advantages, disadvantages, and the analysis? Like we have done the analysis for unearthed system now, we can also do the analysis for resistance earthing system, reactance earthing system, that is low reactance earthing system and high reactance earthing system, which is known as Peterson coil earthing or arc suppression coil earthing. Maybe I think maybe a month from now we may conduct a second webinar, in which we will discuss the earthed systems more elaborately. Now I think I am open for questions now.
Yes, sir. We have 8 to 10 questions, so I'm requesting to the participants, those who are interested to ask question, please post it in the Q&A. So I'll just take a relevant question that may be relevant to today's subject. So Bharat is asking, please advise right time to check earth resistance value.
Sir, this is there are two approaches. One, IS 3043 says one thing, and CEA says one thing. In practice, I would say that every year you please check. It is better to keep a record every year. Once a year on a dry day, it is better to check it on a dry day, measure the earth resistance, and generally in my 40 years of experience, I have most aware whenever I was in charge of installations, whenever I was in charge of electrical installations, we used to measure the earth resistance once a year and keep a record of the same. So I would recommend once a year.
So we have another anonymous attendee. What does it mean, double earthing of equipment, and how to check it during physical inspection?
Sir,
Please,
yeah,
go ahead, sir.
Double earthing means this is again a topic of contention. I am seeing a lot of discussions in our WhatsApp group. So my perception and my installation, wherever I go, double earthing means there are two earthing connection points in every equipment. Suppose if you take a motor frame, diagonally opposite they will provide two earthing bolts. If you take a switch gear, at the end of every switchboard, they extend the earth plate, internal earth plate of the switchboard at two extreme ends. If you take a transformer, they will give two earth connection termination points. So, two distinct and separate earth connection means take two connection from these two terminals and connect to the nearest earthing grid. That is what I had been practicing, and this was approved by many electrical inspectors, and the systems are working all right. That does not mean that two separate connections to earth electrodes. It is two visible connections to the nearest earth grid. That is what is my perception, and this is what I have been practicing. Suppose in a cable tray below the panel, you run a earth conductor, you connect your switchboard's extended earth flats to the earth flat running in the cable trench. Maybe again there is a question of there are somebody lays two earth flats on two sides of the cable tray, somebody runs only one. My contention is, suppose wherever I installed the motor, suppose in an area where there are series of motors are there, indoor or outdoor maybe, we used to put one earth strip, 50 by 6 or 70 by 8 depending upon the calculation. We run one GI earth strip below the ground, and each equipment we give two risers from that single earth conductor. We give two risers. We connect the equipment earth terminals to these two risers using separate and distinct connections. Maybe AGI flat or AGI wire, depending upon the rating of the equipment. It could be a 8 gauge wire, or it could be a 25 by 3 flat or 25 by 5 flat. This is my understanding. This is what I have practiced and it was also not objected by authorities.
So I'll take the question from Santosh. How to
Yeah.
select correct rating of lightning arrestor for undergrounded system?
See, unearthed system, you have to the rated voltage of the earth. In fact, the standard IEC standard gives you a beautiful graph, selection of surges rated voltages depending upon the R0 by X0 ratio and X1 by X0 ratio. There is a graph in the standard. So maybe in a subsequent presentation, I will discuss selection of lightning arresters. But to answer your question, rated unearthed system, if you want to provide lightning arrestor, highest system voltage into ground fault factor. The ground fault factor for unearthed system is 1.732. So suppose you want to install a surge arrestor for a 11 kV system, you got to, the rated voltage is 12 into 1.732, somewhere around 20 kV arrestor you have to put for 11 kV system, 20 kV arrestor you have to put. That is what the standard says.
Sir, this question I have to read out very slowly so that you understand. The question from Nandu Gopal. For a hospital operation room, we are supposed to follow IT system. Then won't transient over voltage be really dangerous? Then does the high impedance thing which is done on the load side reduce this? I'll repeat this question. For the hospital operation room, we are supposed to follow IT system. Then won't transient over voltage be really dangerous? Then does the high impedance earthing which is done on the load side reduce this?
Yes, this is a good question. Now you have to understand, we do not say that transient over voltage happens always. The transient over voltage happens in a most improbable situation when the network inductive impedance becomes equal to the leakage capacitance, which is the possibility when you have lot of inductive loads connected in the system, as it happens in industry. What is the proportion of inductive reactance in a hospital area? Or now you put a isolation transformer. Generally, you put a isolation transformer. We generally recommend to put a separate transformer, isolation transformer, whose secondary is kept unearthed. So, what is the probability of the situation where XL will become equal to XCG in a small network? Yes, separate analysis has to be done. But then in that case, yes, there are chances. Generally speaking, in unearthed system, transient over voltage chances are there. We would suggest to go for SPDs, generally protect equipment damage by providing appropriately rated, appropriately class of SPDs then. That is the answer. But yet the case-to-case basis, depending upon the percentage of inductive load in the hospital network, downstream of the isolation transformer, and what is the capacitance involved, leakage capacitance involved, we can definitely derive at the precise over voltage what we will experience. We can further, if the network details are available, we can give a solution, we can give a suggestion.
Sir, Kamalesha is asking, you mentioned about book Evolution of Earthing. They want to know how, where to get, who is the author?
Sir, the KES technique itself is there, sir. I will, the title I have forgotten, I will just search and let you know. It discusses evolution of earthing systems over the world. I will just give you, it is the same KES techniques from Schneider. There are about 130 publications in KES techniques. One particular publication discusses evolution of earthing systems across the world. I will give a title after I search in my laptop, and I will give the title. I will give you the title in the group.
Okay. Anonymous attendee, how to protect a worker from receiving an electrical shock in an ungrounded system?
Actually, as we saw in I suppose I read it as ungrounded system. In ungrounded system, unless there is a huge capacitance involved, there is no shock risk, because there will not be closed circuit, will not be there, current flow will not be there. Nevertheless, follow all the safety practices, wear safety shoes, stay on rubber mats, use gloves, follow all the safety rules. Definitely he will not be affected. See, PPE is must. Leave alone all these things. Personal protective equipment are must. Notwithstanding whatever said and done, ask the worker to wear PPE properly, shoes, gloves, all those things. Stand on a rubber mat, he will be protected.
Sir, Harish Maghu is asking, sir, the increased frequency of fire in hospitals, is it mainly due to unearthed systems?
No, definitely not. Because fire is again matter of heat, which is a matter of current. In unearthed system, the fault current is negligible. Earth fault current is very negligible. There are other reasons. I would rather say it could be a face-to-face short circuit in an unearthed system, or a face-to-ground short circuit in an earthed part of the hospital network. I don't think that the entire hospital network operates on unearthed system. My understanding is only critical areas in a hospital are operated unearthed. Not the entire hospital network operates unearthed. I may be wrong, but this is my perception. Entire hospital network is not operating unearthed. Other lighting, other air conditioning, lighting, all those loads will operate from a earthed source only. Maybe the probable cause of fire would be that. Could be that. Maybe sitting in this room, I cannot comment any further. A case-to-case analysis has to be done.
So, question from Smruti Pradhan. DG set installed for temporary power supply. We need not earth its neutral and run it as unearthed system.
I am very sorry. The perception that we need not earth itself is wrong. The moment you have a voltage above 250 volt, as per the CE regulation, as per the IS 732, as per Indian standard 3043, you must earth temporary or permanent. You must earth the DG set. There is no question of unearthed system. When you operate a DG set unearthed, you are risking the life of somebody. You are risking the installation. So please do not do that. We need not itself is wrong. You need to and you must.
Sir, can you unshare the screen, sir? The screen still there. Can you unshare the screen?
Unearthed.
Okay, yeah. Now, question from Kishan. In power plant, any unearthed system used?
In power plant, any unearthed system used means I have not come across. Generally, when you operate multiple generators, generally to avoid the neutral switching and all, yes, avoid the neutral switching and all, what they will do, they will, rather than practicing earthed generators, they will practice bus earthing actually. Bus earthing using a zigzag transformer. But I have not come across a power plant where unearthed system is used. If anything is there, I would like to learn also. As far as my knowledge goes, I have not come across any such system.
So, Nikhil Trivedi is asking, when system is earthed through NGR, why cable need to be unearthed cable? Because cable are enough strong or not enough strong to withstand the pH voltage, and relays are more sensitive to trip in a fraction of a second.
Sir, see, even in a NGR earthed system, please understand, during suppose you have a NGR means one terminal of the resistor is connected to neutral, other terminal is connected to earth. Suppose assume in a NGR earthed system, R phase gets grounded. Then NGR, one terminal is connected to earth is raised. Even in that condition with NGR does not ensure earth is always at neutral potential. In solidly grounded system, you ensure that earth is always at neutral potential. But the moment you introduce a impedance between earth and neutral, the earth is no more during fault condition. Earth is never at neutral potential. There is always a potential difference. Earth, the moment you introduce an impedance, the resistors, one terminal will be at neutral potential, and between earth and neutral there is a huge impedance, resistance. Now the earth, suppose R phase gets earthed downstream anywhere in the network, now earth will shoot to R phase potential. Earth will not go to neutral potential. So any cable connected, the armor will be at R phase potential. The inner conductor, Y conductor will be at Y phase potential. B conductor will be at B phase potential. Definitely, if you use a earthed system cable, the cable insulation will be very thin compared to unearthed cable design. So definitely there will be a huge leakage current flow will be much larger, because generally it is designed for armor is assumed to be at 0 voltage. Now armor voltage is raised. Instead of let us say phase voltage, it is now line voltage. So root 3 times the voltage increases, the leakage current through the insulation, cable insulation increases by root 3 times. It will not fail overnight. It will start deteriorating the insulation over a period of time. In one unexpected day, even when there is no fault, even for normal voltage leakage current, it will fail. That is what happens in most of the cases. The deterioration is gradual. So that is the reason, if you provide a unearthed cable, generally for 6.35 kV unearthed is equal to 11 kV earthed cable, the insulation will be thicker, deterioration will take a longer time, or it may not deteriorate in the same way as you use a earthed cable. So definitely, the moment you introduce a impedance, the cables are, it should be treated as good as UE system only.
Sir, Ashay is asking why instrumentation cables are at only one point.
Instrumentation cables are earthed with only one point, means to avoid circulating current, and the circulating current will interrupt. Instrumentation cables are carrying very weak signals, actually 4 to 20 milliampere signals, I believe, or 0 to 10 volt. The system itself is very weak, carrying weak signal. Suppose you earth at both end, during a earth fault, they will start carrying current. The shield will carry current. If the shield is carrying current, it will produce its flux around it. This flux will interfere with the flux produced by the main conductor, and it will interfere, and the signals are weakened. So it may add or it may subtract from the main signal flowing in the main conductor. The readings will be erratic, the control will be erratic. To avoid that only, we earth at only one point, so that you don't have a circulating current and the interruption noise. We call this noise problem. To avoid this noise problem only.
For transmission and distribution, which system is used in India, earth or unearthed?
For transmission system, I think they are going for earthed system, star networks actually. But to reduce the insulation cost of the equipment, step up equipment at the high voltage side, they use a earthed at the source. Suppose you take a 400 kV system or 230 kV system, the transformer insulation cost will be between the phase insulation value and the earth insulation, the line insulation value, the costs are huge as the voltage goes up. So what they do is they generally use a earthed system at the source, but the transmission is 3-phase 3-line system. For distribution also, most of the cases they use earthed system only to reduce the insulation cost. That is why they, since they are using a earthed system only in main substations, you produce a earth mat, assuming that earth will act as a fault current return path and flow back to the source neutral. So this transmission networks, generally to reduce the insulation cost, they would go for earthed system at the source. But exceptions could be there. I am not very well aware of that.
Sir, Om Bapat is asking how to select length and diameter of earthing electrode for earthing system.
There is a formula available in IS 3043 for each plate earthing. There is a formula which takes the dimensions of these things into account, L by D. If you see the formula for earth resistance calculation of pipe or rod electrode, both the length is there, both the diameter, both are there in the formula. So you put the resistance value you want and arrive at the D and L. The IS 3043, there is a precise formula showing the L and D.
Gaurav Mishra is asking a very interesting question. Why electrical and instrument earthing is separate while both have same ground potential.
It is a very, very wrong concept. Earthing and power supply earthing and instrumentation earthing should be separate itself is a very wrong argument. There is a standard, even though we do not have a precise standard in India, there is a IEEE standard 1100, recommended practice for earthing of electronic equipment. IEEE 1100 very precisely says that there should not be any isolated grounding. They put a cross in the word isolated grounding. There should not be any isolated grounding, whatever may be the reason. So there should not be, you keep isolated grounding, problems increase actually. So there should not be isolated as per standard. Only known standard in the world for electronic equipment earthing is IEEE 1100. IEEE 1100 prevents or advises not to keep isolated earthing. All the earthing in the installation must be linked together. That is what they recommend. That is what is recommended in IS 732 also. All the earthing installations must have a common link, interlink. It should not be separate rather.
Sir, Guru Charan Singh is asking, what is the distance between two GI strips?
2 GI strips, 300 mm.
300
GI strips, when you run the GI strips in parallel, he means
yes, yes.
Sir, the larger the better, sir.
Okay, minimum 300 mm.
300 mm we used to lay in around 300 mm. Suppose space constraint is there, because the problem is interference only. Suppose the current flows, we apprehend interference. The larger the better, but even 300 mm is sufficient.
So, Anand Gopan is asking, if there is no PE conductor in an IT system, how is the SPDs connected in case of induced lightning surge after the isolation transformer?
Who said that there is no PE conductor in unearthed system? There is. Please understand, when we say unearthed system neutral is not grounded. Equipment grounding is mandatory. When we say, whenever you talk about unearthed, the term unearthed is related to the current carrying conductor. Even in IT system, isolated earthing system, please remember the terminology itself is the network classification. IT system, in the network classification TN, TT and IT system, the first letter stands for how the system neutral is grounded. T stands for terra. Terra in French means natural soil or natural earth. So in IT system, the first I stands for the system neutral is isolated from natural earth. So that is I for isolation. When the second letter in the network classification stands how your equipments are earthed. That is non-conducting, that is exposed conductive part and extraneous conductive parts are earthed. If you see an IT system, the second letter clearly says T. That means all the exposed conductive parts and extraneous conductive parts must be connected to natural earth. So the assumption that there is no PE conductor in IT network itself is wrong. You need a PE conductor, it must be connected to the local earth electrode. Yes, that is the understanding is wrong. There is definitely there is a PE conductor. There is a earthing conductor and a earth electrode in IT system.
Okay. Sir, Amresh Prasthi is asking, what is PT over voltage factor?
What is PT over voltage factor?
What is PT over voltage?
Yeah, I will explain. See, you are installing a PT. Always a PT is installed either delta or star. Most of the PTs are installed star. Even standard says for delta also. So let us assume PT is connected in star. It is connected between base and ground. So it is not that always the PT is experiencing a normal system voltage. So the standard says there is a possibility of a fluctuation of over voltages during normal operation without any fault. The PT standard assumes worst case there could be 20% over voltage continuously persisting in the system. So irrespective of the method of earthing, the over voltage is specified in two parts. One is continuous over voltage, which is 1.2 continuous. So every PT must be designed for tolerating 20% over voltage continuously. This is expected in the system. So 1.2 continuous is a must. Power frequency over voltage, suppose the transformer tap is kept in the lowest tap, at the same time system fluctuates on the plus side. So worst case could be plus 10% and plus 10%, 20%. So this is one part. Second part is during earth fault. What will be the one side of the PT is connected to ground, one side is connected to the live bus bar. So when there is a earth fault, the earth potential probably depending upon the type of earthing, the earth potential may rise. So in solidly earthed system, they say depending upon the impedance involved in the earth fault circuit, they say there is a possibility of this voltage going as high as 50%. So they say in earthed system, 1.2 continuous, solidly earthed system, 1.2 continuous and 1.5 for 30 seconds. So why they say 30 seconds? Since it is a solidly earthed system, the earth fault current is going to be very huge and some protective relay will definitely act within 30 seconds and it will be isolated. So solidly earthed system 1.2 continuous and 1.5 for 30 seconds. In resistance earthed system or low impedance earthed systems, the same thing, 1.2 continuous, but they experience 1.8 times over voltage. They say 1. Whenever in NGR earthed system or reactance earthed system, again as I said, whenever the fault happens, earth does not go to neutral potential as in solidly earthed system. Earth is raised to the fault at phase. So the voltage now is earth is now at a different phase. So each phase will see other phase. Suppose Y phase will see with the ground R phase. Suppose R phase is grounded. Blue phase will see with earth it will see R phase. So it will be raised to line voltage, that is 1.732 times. So standard has rounded it off. Impedance grounded system where there is a provision of isolation, current detection is possible. That is, you say you have put a NGR, but say let us say you are limiting the current to say 300-400 ampere earth fault current. Now you can easily provide a CT and a earth fault relay. So there is a possibility of current detection and isolation. If the system is like that, network is like that, the PT over voltage factor should be 1.2 continuous and 1.8 for 30 seconds. Then third option they are giving, you do not have any current flowing during earth fault, like an isolated earthed system or very high impedance earthed system, Peterson coil earthed systems, or in high reactance earthed system, high resistance earthed systems, you are limiting the current to say 10 amperes. In that case, isolation is not possible. Current detection, earth fault current cannot be detected and cannot be isolated. The standard says 1.2 continuous and 1.8 for 8 hours. Why they say 8 hours is, it is an evolution. In the unearthed system, the first fault cannot be isolated, but it can be alarmed. You can put a neutral monitoring relay. They say neutral, there is between neutral and earth, you put a voltage relay. Whenever earth fault happens, there will be a voltage appearing across the neutral and earth. It can be alarmed. Look, dear, there is a earth fault somewhere in the system, one phase to earth fault. There is no hurry. Maybe in the shift gap, you can repair it. That is what they say. So a shift timing normally is 8 hours. Suppose unfortunately during the start of the shift, there is a one line to ground fault. It is alarmed. But the production has started, you cannot interrupt. So when the first shift to second shift changeover happens, you have some time for locating the fault and rectifying it. So the people assumed the unearthed system, first line the ground fault can prevail for 8 hours. So they say the PT has to withstand this 1.8 times. That is roughly 1.732 times, rounded up to 1.8 times. 1.8 times voltage, it's rated voltage for 8 hours. That is generally a one shift time. So these are the various over voltage factors PTs are designed for. The higher the over voltage factor, the cost and size will be more. So for solidly earthed system, you need not go for 1.8 for 8 hours. You simply be happy with 1.5 for 30 seconds.
Okay. Sir, we have many more questions coming. I will Lakshmi will forward you this
Please, sir,
question.
please.
So whenever you find time, probably you can answer. We are now 12 o'clock, 18 minutes. So we are going to conclude. This is a very, very interesting session. As you said, yes, we need to have a part two, session. Probably we can do it in end of July. So or first week of August, we will do it. And we had a wonderful attendees, over 320 at time. So we have many questions, so we will be putting up the questions to Mr. Shivkumar. So conveniently, he will write you by email. And all the recording of today's session will be broadcasted on Monday. So everybody, people who have missed, people who attended, will be getting their video recording of the whole session. So I want to thank Mr. Shivkumar for sparing such a valuable time with us. And, this is a 1 hour session, was very enlightening. And we will come back again with Mr. Shivkumar on the same subject as a part two. And we'll be taking up furthermore case studies and question answer.
Thank you, sir.
Thank you, sir. Thank you for sharing your, wisdom to all these people who attended. I would request every engineers who are participating to become a member of NFE. My colleague Lakshmi continuously posted. This is a very healthy discussions we keep happening in the WhatsApp group. So please join, and you can continuously in touch with experts like Shiv Kumar. So he is very active in the WhatsApp group also. So the advantage of becoming a member, you can attend all our program, webinars, interact your doubt on the WhatsApp group, and attend various seminar that is happening. So our upcoming seminar is in Cochin on 7th of April on National Electric Code of India 2023. So those who are interested, please share your mail ID to Lakshmi, or people, she would have definitely shared the registration link to you for Kerala seminar. So next webinar will be on lightning protection for structure. So we will let you know by email, and you will get the notification. So thank you very much. You have a great weekend, and stay safe. Looking forward to see you again. Thank you so much. Thank you,
Thank you,
Mr.
thank you. Thanks the participants, thanks the organizers, thanks NFE.
Thank you, sir. Bye.